Okay, everyone, we're going to take a look at number 9 in section 7.2. Here they want us to evaluate the following definite integral from 0 to, that's 11 pi over 2. And again, your numbers might be slightly different. Sine squared of 17x. Remember, this is the same thing as sine of 17x and then all squared. So I'm going to do a little substitution here just to clean things up a little bit. Let u be 17x inside that sine squared function. Du is 17 dx then, or 1/17 du is dx. I'm also going to change the limits of integration since I'm going to the u variable. When x is 0, since u is 17 times x, u is just 17 times 0 or 0. But when x is 11 pi over 2, u is 17 times 11 pi over 2 or 187 pi over 2. So my new integral becomes 1/17 du is the dx, sine squared of u, and my limits, as I showed you, just changed, right? From 0 to 11 pi over 2 to 0 to 187 pi divided by 2. Now, what's the antiderivative of sine squared u? Well, recall we derived this one in class, and the way we derived it is with the power reducing formula for sine squared of x is 1 minus cosine of 2x divided by 2, or 1/2 the quantity 1 minus cosine of 2x. And that's what I've done here. Of course, I've got the variable u, so mine is 1/2 1 minus cosine of 2u. So find the antiderivative, pull that 1/2 out. And then what's the antiderivative of 1 with respect to u? It's eu. What's the antiderivative of cosine of 2 theta? Well, it is 1/2 sine of 2 theta. And the 1/2 comes from a simple substitution, right? If you let w be 2u, then dw is 2 du. And so 1/2 dw would be du. And so, or sorry, 1/2 dw would be du. And so we would have that 1/2 out there. Cleaning this up, distributing the 1/2 through, it gives me this. And so here's my antiderivative. So this definite integral, the 1/17th, don't forget about that. Antiderivative here, don't need the plus c, remember. And evaluate at the upper limit and the lower limit. When I evaluate the upper limit, I get 187 halves times a half is, or 187 pi over 2 rather, times 1/2, 187 pi over 4. And then I get 1/4 sine of 2u. So if I plug in this for u, I get 2 times this. The 2's cancel. I just get 187 pi. Notice that sine of any multiple of a pi, right? Sine of pi, 2 pi, 3 pi, 4 pi, and so on is always 0. So this will be 0. And then minus, evaluate this whole thing at 0. Of course, if I plug in 0 there, I get 0. And sine of 0 is also 0. So this whole thing will be indeed 0. And so the only thing I'm left with is this. I get 1/17 times that, which is 11 pi over 4. And that is the exact value of our definite integral. Hope this is helpful.